Let's get started and continue discussions we had. We've talked about firewalls, and we said that firewalls are systems that we put them in our organizational network or system in order to detect malicious activities and prevent them. They kind of look at the packets, they look at the details of packets, they look at the port number, the IP address. Sometimes they look at the multiple packets in order to detect some uh, patterns in the packets. They look at the applications or protocols to see, for example, what part of a protocol is violated or not. And they may somehow stop incoming traffic or stop outgoing traffic because that traffic is not kind of is not detected to be a normal traffic or safe traffic by the firewall. Okay, but there is also another type of system that we call them intrusion prevention systems. I'm going to talk about this lecture. We are going to totally talk about IPSs or intrusion prevention systems. And of course, I'm going to give you kind of the definition and their duty, what they are supposed to do. And one important thing that I'm going to do in this slide here is I'm going to make it clear what is the difference between firewall intrusion prevention system and intrusion detection system. Because I agree if you argue and say that, okay, so we have firewall, why do I have to have IPS as well? And you may also ask, if I have IPS or firewall, do I need to have IDS as well, intrusion detection system? What's the role of IDS if I have IPS or firewall? Okay, let's first talk about the IPS, define them. First of all, they are also called IPS stands for intrusion prevention system, but they are also called intrusion detection and prevention system. So sometimes people they call IPS as IDPS as well. And like what we had for IDS, intrusion detection systems, IPSs also can be host-based, network-based, or distributed. Okay, but there, uh, this is a definition of IPSs or kind of their major characteristics. IPSs are basically extended version of IDSs, and they attempt to block or prevent detected malicious activities. So this definition might be kind of very close to the definition of firewalls. And I'm going to, in the next slide, make it clear what's the exact difference between the firewall and IPS. So they are supposed to detect malicious activities and in some cases block it. This blocking is kind of shaky for IPSs, but of course it's a strong thing for firewalls. IPSs or IPDPSs may use anomaly detection. This is again another kind of categorization or the approaches that people can take in order to develop IPSs. IPSs can be developed by anomaly detection. In that case, they detect anomalies and they identify if the behavior of a user or a traffic pattern is okay, is safe or is not safe, or they can be implemented, they can be developed based on signature checking or heuristic method. In the signature checking, of course, there are some signatures, there are some patterns in the packets or some patterns of packets which are previously defined as, for example, malicious patterns. And once the IPS detects them, once the IPS sees them, the IPS kind of shake the flag and says, okay, this is something malicious and should be stopped or should be blocked or whatever. Okay, this figure, in this slide, I'm going to talk about the differences between the IPS and firewall. First of all, in terms of the place that we put them in our organizational network, this figure here shows if you have a firewall, you put the firewall as the perimeter or at the perimeter of your network, which means that very close to the router you have. And after the router is basically uh, outside your network, and it is basically internet cloud. So you put the firewall here. That's why we also said that firewall is the first line of kind of protection. But if you have IPS, you put the IPS like this. You place it in a kind of between your LAN and the firewall. So by this kind of first illustration, let's talk about the similarities. Similarities we see between IPS and firewalls is they both may block traffic. So the similarity between the IPS and or IDPS and firewall is that they firewalls for sure blocks the traffic. In some cases, IPS also blocks the traffic. So this is a similarity that we see. Of course, firewall does the blocking or performs the blocking based on some rules or some access policies. You remember in the last kind of video, we kind of talked about them in details, that how those access policies may be developed and what are some examples of those access policies. But in IPS, the detection takes place based on some algorithms and some pattern detection mechanisms. So now let's look at the difference. What is the difference between the IPS and a firewall? In a firewall, we always accept the firewall to kind of take action. So whatever happened, which is for example an unsafe traffic or unsafe application or unsafe protocol, unsafe communication, the firewall is supposed to stop it. The firewall is supposed to block it. So the firewall is kind of given the full authority in order to block all of those packets, and this is what the firewall is doing. The moment firewall detects an unsafe pattern of traffic or unsafe packet or unsafe connection, it immediately stops or rejects that traffic or drops that traffic basically. But this is not the case for IPS or IDPS. They are supposed to, IPSs, they are supposed to detect and alert the system administrator, like what we mentioned in the intrusion detection systems or IDSs. So IPS, similar to IDS, they're supposed to detect anomalies or malfunctioning or threats and alert the system administrator. In IDS, there is no action to be taken by the IDS automatically. In IPS, though, the administrator, the kind of network admin may set up or may configure the IPS for some automatic kind of reactions. So in IPSs, sometimes the administrator allows the IPS to take some actions. So that's why you see that IPS is somehow in between IDS and firewall. In IDS, there is no action while for example, unauthentic or unauthorized traffic pattern or packet is detected. There is no action. What IDS is going to do, IDS is just alerting the system, the administrator. In firewall, there are always reactions from the firewall. In IPS, it is something in between. And it depends if the administrator has previously allowed the IPS or not. So the IPS may take some reaction or may not, but always kind of alert the administrator. So this is the kind of the major difference between the IPS, IDS, and firewall. Okay, this slide somehow summarizes what I mentioned. It's a table that says the philosophy of firewall, for example, is a first network security level, and it's going to be placed at the perimeter of our system, of our network, and it filters traffic based on IP address, port numbers, and protocol behavior. A firewall sits in layer 3 of network. In terms of placement, it's going to be placed at perimeter. It doesn't analyze traffic mostly. It is the first line of defense. It always blocks the traffic, and it it may work based on stateful filtering or packet filtering or stuff like this. But IPS, inspects the traffic and detects or classify the uh, traffic or packets, and that's it. And alarms or alerts the administrator. Of course, the inspection is supposed to take place in real time, and it might be through some anomaly detection or signature checking. And in some cases, it may, like I said, if the administrator has already allowed, the IPS may block some of the packets or some of the traffic. It is in line generally after firewall. It analyzes the traffic, should be placed after firewall. Yeah, it works based on anomaly detection. It also may work based on signature detection, and sometimes block it. So yeah, this is basically the summary of what I mentioned about the IPS, IDS, and firewall. And of course, IDS is the version of IPS that never blocks; it just alerts. Okay, now let's get back and talk about intrusion prevention systems, or IPSs. If you remember, we mentioned in the very first slide that IPSs can be developed, can be implemented either at host level, which are called host-based IPSs, or at the network level, which are called network-based or network level IPSs. Okay, now I'm going to talk about HIPS, host-based IPSs. For today's attendance code, please use HIPS. Please use HIPS all uppercase for today's attendance code. Okay, in HIPS or host base, that they can of course, what they're doing is that they're placed at the host, at the host computer or the host workstation we want to protect it. And of course, they can use either signature or heuristic or anomaly detection techniques to identify attacks. In the signature, like I mentioned, they focus on a specific content of application network traffic or a sequence of system calls. Okay, here is when we say signature, this signature might be some signature in the network traffic, or it might be some signature through kind of sequence of system calls. What are the system calls which are being invoked on that specific system, or looking at the pattern that have been identified and compare them against kind of the pattern that are called abnormal or malicious. And in anomaly, IPS is just looking to the behavior and try to label that behavior, if that behavior is normal or abnormal. Some example types of malicious behavior addressed by HIPSs are here. Modification of system resources. If someone comes and modifies some of the system resources. Privilege escalation. Some users have some levels of privilege and they try to expand or escalate that level of privilege. That's of course something that violates the security policies and it shouldn't happen. So the HIPS detects that, and if the administrator has already allowed, the HIPS may block that. Buffer overflow exploit. We haven't talked about buffer overflow in this course, but that's one of the type of attacks that they try to they try to use memory of the system as much as they can so that there is no enough memory for other applications or other kind of important applications. And if you don't have if you don't allocate enough memory to those applications, what would happen to them is that they're going to be delayed, and that delay might be kind of very harmful to them if they're transferring some real-time traffic. Access, they may HIPSs, they may detect accesses to email contact list if they happen, and directory traversal. If someone comes and tries to traverse various directories of a workstation or a computer, the HIPS should be able to detect that. And of course, like I said, if the administrator has already allowed, they may prevent the kind of activity. Okay, one good thing about HIPS, which is similar to HIDS, we also had this for host-based intrusion detection system, is that we have the option to kind of customize them for our specific platform or for our specific host condition or situation. So the opportunity or capability of being tailored means that you can add or remove. For example, you have a database server, and that database server is supposed to work with databases. So attacks related to databases, like for example, SQL injection attack, should of course be addressed there. But if you have another server which is not supposed to work with databases, it's just let's say uh, an email server. So in that case, database attacks might not be the critical case there, and you may remove that portion or that option from your HIPS. So the option for kind of customizing HIPS while we are developing intrusion protection at the host, we can kind of tailor them down or customize them with respect to the features that we exactly require. A set of general purpose tools may be used for a desktop or server. Yeah, if you are using for a kind of works, if you are trying to protect a workstation computer using HIPS, a set of general purpose or kind of a set of general features for HIPS may be used, which is again good. It means that you have the option for customization. You can customize your HIPS if your server has a specific requirement. If you don't have such requirement, you can go with a kind of a baseline or a solution that fits to all workstation or many workstations. Yeah, I've talked about this, that some HIPS packages are designed to protect a specific servers like web servers or database servers, stuff like that. Okay, another good option that HIPSs may use and may kind of take advantage of is that HIPSs can use sandbox approach. What is a sandbox approach? I guess we've talked about it in one of our previous lectures. Maybe it was the second or third lecture, but I'm going to kind of refresh your mind. A sandbox approach is kind of a security approach at which the entity you want to allow a new entity to work with your resources, to work with your assets, but you're not 100% sure about that entity. When I say entity, it might be a piece of code, it might be a new user, it might be a new application, whatever that thing is. That entity is new to your system, and you want to allow it to interact with your assets. You want to allow it to use some of your assets, but since you are not 100% sure about if it's a legit or, for example, hacker or attacker, or a hacker developed application or a malware, you do a sandbox approach. In a sandbox approach, you put the entity that you are kind of suspicious to, you put it in a control situation, and you kind of monitor the behavior of that entity. For example, you define a virtual environment, you put the entity there, you let the entity to run on that environment. And you monitor, of course, when I say you, I mean the operating system monitors uh, the the behavior or the interactions of that new entity. If that entity works perfect and doesn't violate any security policy, it means that we can probably trust that entity. And if that entity kind of starts doing something malicious and starts violating some of the security policies, we can make sure that this is something that we shouldn't trust it. Sandbox, this is called sandbox approach. Sandbox approach can be used by HIPSS. HIPSS can kind of have that environment and can use it in order to do sandbox analysis. And they are very good for kind of for investigating the mobile codes, for example, Java applets or scripting codes that they may come when you browse internet. They may come and some servers may run something on your machine. So if you have a HIPS on your computer, on your workstation, that HIPS can quickly run that code in a control environment, in a sandbox. And if the code is kind of clean, is not trying to do anything suspicious, they let it to be run on your real computer. Otherwise, they block it and they prevent that communication. So areas at which HIPSs typically offer desktop protection are these. They can protect system calls, file system access, registry setting, and host input output. These are all kind of areas that can be protected using HIPSs. So it's not only about the network. HIPSs can also be used to protect kind of local assets of your system as well. Okay, uh, along the same line, I'm going to talk about role of HIPSS, and it actually it is based on the new trends that we see in the security. Uh, Nowadays, many kind of observers, many industry observers, or many security observers, they started seeing that okay, endpoint systems or workstations, desktop, laptop computers now are kind of are changed to be the main target of hackers and attackers. While it wasn't like this kind of traditionally servers and kind of main computers in a network are supposed to be excuse me are supposed are kind of are supposed to be the main victim of the security threats and security attacks. So having this in mind, having this new trend in mind, if we look at the protections that we used to use for our endpoint systems or computers, our kind of user workstations, we used to have, we used to use a collection of security solutions. So endpoint security has been provided by a collection of distinct products. For example, if you remember, we used to have antivirus plus anti-spyware plus anti-spam plus personal firewall and stuff like this. And these were each one was a different application, and sometimes they even used to come from different companies. For example, you used to buy your antivirus from, let's say, Symantec, and anti-spam from somewhere else. So, but that that's something that we used to use it for. We used to work with it for many years until maybe 4 or 5 years ago. But now having this kind of shift in the target community, in the victim community, why not integrate all of them together? So the answer to that question is HIPS. If you have a HIPS in your computer, in your workstation, you can basically have all of these products to work as a part of your HIPS. So we can see, or we can develop HIPSs that are basically an integrated single product suite that functions or performs all of those uh, functionalities and offer all of those functionalities. And of course, this is good. What are the pros of this approach? If you use HIPS and a workstation or endpoint computers as a single solution that offers antivirus, anti-spam, anti-malware, and anti-whatever, there are many kind of advantages in that. The first thing is that everything is developed by a single company, by a single developer, and having those various tools working together or working on the same umbrella, it makes them to work very closely, and that of course improves your security. And threat prevention becomes more comprehensive because those sub components of that HIPS now can communicate very easily and can share information. So previously my antivirus was maybe it wasn't kind of able to, or it didn't want to share information with my let's say anti-spam. But now, since all of them are developed using a base by a single company, or they're subcomponent of a of a one single product, it's very easy to have them share information and share what they found. So, and the threat prevention becomes more comprehensive and more kind of strong. And of course, the management is going to be easier. And the cost also is going to be less. That cost points to the dollar amount that we pay to purchase that product, and also the computer cost, the amount of memory or processing power that we put, or the amount of energy that we use for the protection of our computer. Of course, one kind of brilliant or kind of super strong idea or approach is to use HIPSs as one element in a defense in depth strategy, which means that you have HIPS in your computer on your workstations in order to protect them, but at the same time you have also network-based IPS, network-based intrusion prevention systems as well. It means that you don't leave the whole network. Since I have HIPS, since I have host-based intrusion prevention system on computers, okay, let's forget about the network. No, if you use both of them at the same time, it's going to give you multiple layers of protection, which is again something that we mentioned is one of the principles of the security, and we of course want it. Okay, the next kind of development approach or development way that we can take in developing an intrusion prevention system is called network-based IPS. In a network-based IPS, of course, this is exactly similar to a network-based intrusion detection system with some extra kind of functionality or authority. The extra authority is that we give the NIPS the authority to modify and or at sometimes discard or reject some of the packets, or tear down or kind of stop the TCP connections. And of course, all of these are going to be happen based on the administrator person's discretion. If they like to do that, they give this kind of permission to the IPS. Again, they may have been developed based on signature detection or anomaly detection, and methods used to identify malicious packets in NIPSs are these. They may look at this. Of course, these are some example of the parameters that they look, but or methods that they take. But these are the most important one, most widely used them. They may do pattern matching. They scan incoming packets for a specific byte of or sequence of bytes in a packet, and kind of compare it against existing signatures. And if that signature is found, that traffic is going to be rejected or denied. They may do stateful matching, which means that they scan a flow of packets or a stream of traffic to find that signature. They may do traffic anomaly, which means that they watch the traffic behavior or traffic pattern and they just always label it if it's something normal or abnormal. And for example, if flooding UDP happens, that's not a normal thing and it's going to be labeled as abnormal. And lastly, they may do statistical anomaly detection, which means that they try to somehow model the normal traffic, and that model is going to be used against abnormal traffic. That normal, of course, should be developed by some people, by some researchers and or some developers, and that statistical model will be used in order to say what is normal, what is abnormal. Traffic anomaly and statistical anomaly are very close because you may argue, you may say that for anomaly detection, at the end of the day, I have to have some type of reference to compare against. Yeah, that's true. Sometimes we have an analytical model or a statistical model, but sometimes we have other types of models. For example, neural network models also can be used here. Okay, what I'm going to give you is to give you some is to give you one example. Here is an NIPS which is developed by a company called Secure Marketing. This Secure Marketing company developed an NIPS, and here are some of the attacks and countermeasures that this specific NIPS can detect. Of course, some of the attacks we may not know, but some of them we know, and we can see how we don't see how they detect it, but we see their countermeasure, their reaction. For example, the sink flooding attack. You remember we've talked about sink flooding attack and TCP sink attacks. This is all about TCP connections. If the NIPS detects a sink flood, what they do is that they close the TCP session. They kind of reject the connection. But we also have other things. For example, invalid port number. The port number is not valid or is something that doesn't match, or invalid sequence number. In that case, the NIPS enforces or correct the TCP port number or correct the sequence number. Another example from the case that it blocks the connection, blocks the traffic is here. Random data as TCP. If random data comes in a TCP connection, means that someone is flooding information toward us. The NIPS manages the TCP timeout session, which means that basically after, if it shortened the timeout, it means that the traffic is going to be blocked. So here are the some of the countermeasures, some of the attacks they detect and their countermeasures or the protections for TCP connections. The same thing for UDP. For example, if a packet comes with the invalid UDP packet, the protection that NIPS of this company is doing is kind of tries to correct it. If a random UDP comes, it drops the UDP packet. And other attacks that we haven't talked about. So these are some examples of the kind of protections or reactions of that NIPS from this company. Of course, there are many solutions online people can buy. I just put them here to give you some kind of idea that how they exactly, when it comes to real actions, how do they take the action, or what are the examples of the reactions that NIPS may take. Okay, I think that should be it for today. I appreciate your time, and please get ready for the final week, and I am looking forward to see your research presentation, your course papers, which is due on the last day of the classes. And have a good rest of the day. Bye-bye.